All right, so this is slope fields. This is number 49. And instructions to this, let me get a different color here. Instructions to this say a slope field or direction field by the way, have you ever played around with magnets and metal shavings?
The metal.
Looks a lot like this, okay? So just something that you can grab onto that you know probably from the past. It gives a visual perspective of the slopes of solutions of the different differential equations. So sketch 2 approximate solutions of the differential equation on the slope field. So you're following. Are you being sarcastic? Yeah. Okay, I didn't know because I'm like really bad with this sort of thing. I don't ever remember doing this when I took calculus. So one of them, whoa, I thought I straightened and I'm off that. I thought, okay. So one of them they want me to. Technology. Let me try it again. They want me. All right, let's try it now. One of them they want me to go through 4-2. So I see that they have labeled 4-2 right here. So what I'm going to do is follow along these slope lines here. And I'm going to try to trace along them and I get a little lost on these. But you're trying to follow the directions of the line. So that would be 1. They wanted 2, so let me go back and pick a different color. I'll use purple, for instance. Like, let's say I start in here. I follow the lines. And basically, it's almost like the functions are just all parallel to each other, even though they're not straight lines, if that makes sense. Like, you could tell I got off right there. I should have gone more straight up there. But you're just tracing along those lines to try to follow the direction of these little arrows. So they go in there. There's one section of the book where they make you actually create these.
Oh, God.
Yeah. I think maybe we skipped that because I just couldn't bring myself to make y'all do that, because you look how many times you'd have to evaluate that function at different points, because each one of those comes from evaluating that function at different points. So and seeing if the slope is positive or negative when you take the derivative of it. That's how you do it, is take the derivative. But anyway.
Man, I'm probably making an app to do that for me and just save everyone trouble.
If you read the directions for all these word problems, it says use A of t. So what are we talking about here? A of t. What do you think that's going to be?
Function. Acceleration.
Acceleration due to gravity, right? Remember all this stuff over here?
I'm not wrong. Yeah, you're not wrong.
It is a function. It's an acceleration function. You're both.
I'm not wrong, people.
You're not wrong. Meters per second. So it's meters per second squared. And that's gravity. So that's our function we're going to start off with. And 72 says the Grand Canyon is 1,800 meters deep at its deepest point. That's the depth. Yes, you have a good visual in your head. Write the height of the rock. I guess the rock that forms the canyon. A rock is. Oh, you're dropping a rock. You're dropping a rock from the rim above this point. So you're.
It's actually illegal.
Oh, is it really? Throw something because you might hit somebody and kill them.
Down there. That's actually happened before.
Because it would help to turn the thing on. I'm going to integrate. I'm going to put the negative out front. 9.8 meters per second squared. And then the variable is dt, because it's always with respect to time, when we're doing all the acceleration, velocity, and position, okay? So that's going to be negative, 9.8 t?
Yeah.
Okay? So that's going to be my velocity function, v of t. We don't know the time, plus c, right? Okay, so now I need to integrate that. I'm going to still put the negative out front. 0.98 t. I don't know the c, so we'll kind of figure that out with this point in a minute. dt. Come on, take. So that's going to be negative 9.8 t squared over 2, right?
Yeah.
Plus c is going to be my position function, s of t. Let me write that down because I'm going to need another page to work on. No, that won't glitch the app doing that. Okay, so I've got my position function is equal to negative 9.8 t squared over 2 plus see, and I've got the point. What time, yeah, is the position at 1800. So, let's see, let's simplify that first. That's negative 4.9 t squared.
Mhm.
See if they give me any more information.
Well, we know the point's 1800, so we can use that to plug in for t, right?
Yeah, well, we want to find the time. We're trying to find, it says find, how long will it take the rock to hit the canyon floor, so we're solving for t.
We know what y is, so we're solving for x here?
We know the y is that, yeah, we know 1800, right.
Right, so in order to get to a
Problem I've got,
We don't have enough information.
yeah, if I put that indefinite integral c on there, we don't have enough information. That's why I'm looking back at the problem to see if they gave me anything else.
Once they don't want you to put C in
I
there?
think they don't want me to put C there. That's the only thing I can figure because there's just not enough information. They don't tell me anything else other than it's going to hit. The only other thing I could think of is this. At 0 seconds, it has dropped 0. Maybe I should try that. So let's do that. Because at 0 seconds, at time is 0, the
Well,
rock will have
that's-
traveled 0, right?
That's going to equal 0 equals 0. If you plug it into that problem.
Oh, that gives me my C is 0, right?
Yeah.
Okay, so
then C is
C is 0.
taken out of the equation.
yeah, C is 0 because I can plug in 0, get 0. C is 0, so that means the equation is S of t is negative 4.9 t squared. S of t is, we'll say negative 1800 since it's going down. Okay. So if I divide negative 1800 by 4.9, I'll just negative 4.9. It's going to become positive. We're going to get 367 point, I'll go out 4 decimal places, 3469 is equal to t squared. So if I want to find out the time, I could square root both sides. Second square root, second answer. I get at about t equal 19 point, let's put just 19.2 seconds. It would take it that long to fall. That's a long time.
Yeah.
It's a big distance.
It is.